Today our topic is solving right triangles. Our learning target is how can I use the inverse sine, cosine, and tangent ratios to solve a right triangle. Key terms, solving a right triangle. What does that mean? It means to find the measures of all the sides and the angles of a right triangle. In order to do this, you need two things. You can have either two side lengths. If you know two side lengths, you can solve a triangle, or you need one side length and the measure of one acute angle. Now, technically you have three things because you know it's a right triangle, which means for both of these cases, you know one of those measures is a 90-degree angle. So as long as you know it's a right triangle and have two side lengths, or you know it's a right triangle and have one side length and the measure of one of the acute angles, then you can solve the triangle. Inverse trigonometric ratios, inverse of the ratios, they allow you to solve for the angle measures. So I talked about this in the last video, but this is why we need the trig ratio so that we can solve for the angle measure. All right, the inverse of your tangent ratio. So if tangent of A equals x, then the inverse tangent of x equals the measure of angle A. Kind of a lot of words there, but if we look at the measure of angle A, let's label our sides. We have opposite, adjacent, and hypotenuse. So we know that the tangent of angle A would be our opposite side over our adjacent side. So if we know that the tangent of angle A is the opposite over the adjacent, then to find A, we would do the inverse tangent of the opposite over the adjacent side, and that would equal the measure of angle A. So it's just a little bit backwards. Same for inverse of sine and inverse of cosine, except for you would use your sine ratio and your cosine ratio. So I think these can be learned a lot better if we just start jumping into the practice piece. We put it into practice. So we want to use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So let's look at the measure of angle A. First off, label those sides. So we have opposite side, adjacent side, and the hypotenuse. Now, based off of what we're given opposite and adjacent. So if we think about SOHCAHTOA, tangent piece is the one that uses opposite and adjacent. So we know that the tangent of angle A is equal to the opposite side over the adjacent side. So 15 over 20. Now, we want to know what is A. So we have to use the inverse of tangent, and we're going to flip A and 15 over 20 around. So just like addition and subtraction are inverses, and multiplication and division are inverses, tangent and inverse tangent are also opposites. So to undo one, we use the other. Now to solve for A, we just need to use our scientific calculator. All right, to evaluate the measure of an angle using our calculator, the first thing we need to do is make sure we're in the right mode. So we're going to go to our mode key. And right here where it says degree, we want it to be in degrees. So again, we're going to have to change that over to degree. Press enter. Then we are ready to evaluate. So if we look right here, our tangent key, the inverse tangent is in blue on that key. So if we hit the blue button and then the tangent button, we'll get the inverse of tangent. And then 15 divided by 20 gives us our angle measure. And we want to round that to the nearest tenth. So we have an 8, but the 6 after the 8 tells us we're going to round it up to 36.9. So right here, our measure of angle A is 36.9 degrees. Use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So if we're looking at measure of angle A, let's label our sides. We have the opposite side, the adjacent side, and 11 here is our hypotenuse. We know the opposite and the hypotenuse. So if we're looking at SOHCAHTOA, the sine function uses opposite and the hypotenuse. So we're looking at the sine of angle A is equal to the opposite side, 5, over the hypotenuse, 11. So now we want to solve for what A is, so we have to use the inverse of sine, and then we flip-flop the A and 5 over 11. So the inverse sine of 5 over 11 equals our measure of angle A. Using our calculator, the inverse of sine is the blue button and then the sine button. We get that inverse of sine times 5 divided by 11 and equals, that's going to give us our measure of A. So we have 27.03. So we can just round it to that whole number of 27. So our measure of angle A would be 27 degrees. Next example, we want to use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So if we're looking at the measure of angle A, we can label our sides. We have our opposite side, our adjacent side, and our hypotenuse. So again, if we think about SOHCAHTOA, which piece uses uses adjacent and hypotenuse? It is the cosine piece. So we can say that the cosine of angle A equals the adjacent side, 6, over the hypotenuse, 10. I want to solve for A, so the cosine, inverse cosine, switch these around, of 6 over 10 will equal the measure of angle A. Using our calculator, the inverse of cosine is the blue button plus the cosine button times 6 divided by 10 equals 53.13. We have a 1. The 3 after it tells us we can leave it as 0.1. So our measure of angle A would be 53.1 degrees. Last example for you guys. Solve the right triangle. Round answers to the nearest tenth. So solving the right triangle means we're finding all the angles and all the side lengths. We know it's a right triangle, so we know this is 90 degrees, and we know that this angle is 40 degrees. Using our triangle sum theory, we can determine that this angle is 50 degrees because we know the measures of the angles of a triangle need to sum to 180. So we know that the measure of angle K is equal to 50 degrees. That's the first piece. Now we know the hypotenuse of our triangle, and we want to determine KL. So I'm going to call that side X, and ML. I'm going to call that side Y. We want to solve for X and Y. So for these, we're going to just have to use regular sine and cosine functions. If we look at M, 40, the opposite side is X. So we can say that the sine of 40 equals the opposite side, X, over your hypotenuse, 8. So we're looking at the measure of angle 40. The opposite side is X. Your hypotenuse is 8. So we're thinking sine, that SO piece of SOHCAHTOA, sine of an angle equals your opposite side over your hypotenuse. Now we just need to rearrange this equation so that it's equal to x. So we're going to multiply both sides by 8. We get 8 times the sine of 40 degrees equals x. Now we can use our calculator to evaluate for x. So 8 times the sine, we just want regular sine, of 40 degrees equals 5.14. So we're rounding to the nearest tenth. It's going to be 5.1. So here we can say x equals 5.1. So right here, I'll add that to my list of pieces. We just need one last piece. We need to solve for y. So if we're still looking at the measure of angle 40, our adjacent side would be y, and we have our hypotenuse of 8. So if we think about the cosine piece, so katoa, we know that the cosine of an angle, which is 40 degrees, equals our adjacent side, y, over our hypotenuse, which is 8. Get this with y by itself, so multiply both sides by 8. 8 times the cosine of 40 degrees equals y. We can use our calculator to help us evaluate. 8 times the cosine of 40 equals 6.128. So we are rounding. We should get 6.1, rounding to the nearest tenth. So if we look here, we can say that y equals 6.1. Now we have solved the right triangle. We know all the lengths of the sides and all the measures of the angles. That's all the notes that I have for you today. Please make sure you remember to take your 7.7 notes quiz before you come to class. Thank you for watching my video, and please subscribe to my YouTube channel.